Today's lesson is over dilations and scale factor. The goal is to determine side lengths and perimeters of shapes after dilations have been performed. This will connect very well with yesterday's lesson on similar and congruent figures, and hopefully make that lesson a little more clear if it wasn't yet. So vocab, we have transformations. This is an operation that changes a figure into another figure. It transforms that shape. An image is the new figure created by a transformation. And a dilation is a type of transformation that either stretches or shrinks a figure. And then we have scale factor. This is the ratio of a side length after a dilation to its length before the dilation. The variable k is often used to represent scale factor. Okay, this will make more sense definition-wise as we do examples. But the key here, the ratio order goes side length after to the side length before. Those words are bold-faced for a reason. So for example, we're going to look at the scale factor that was used to create the image. So here's our original figure, and there's the image. Now we look at what happened from the original to the image. So the original, on our corresponding sides, in the original, it went from 10 inches to 5 inches. And then this one, this side, from 6 inches to 3 inches. So we could say that we're dividing by 2. However, scale factor is always done as multiplication. So timesing by 1/2 is the same as dividing by 2. So we could say then the scale factor that was used to create the image is 1/2. Remember, always multiplying, never dividing this stuff. We also want to look at what happened with the perimeter. So we would calculate the perimeter of each rectangle and describe the relationship. So the first rectangle is the 10 by 6. Add up all the sides. Remember, we have to include 10 there and 6 there. The original rectangle has a perimeter of 32. Then the image, we have our 5 and 3. Remember to include those on those sides as well. Add them all up, and we get 16. So the original is 32 for the perimeter, and the image is 16. So what happened? The perimeter was divided in half or multiplied by 1/2. So there's a direct connection between scale factor for side lengths as well as perimeter. It stays the same. Let's think about triangles. Okay, the original triangle was dilated by a scale factor of 3. So now we're giving you the scale factor. What are the side lengths of the image? So here are the drawings. This way is probably a little bit easier. So we're going to change each side length by 3. So we'll match it up there. 3 times 3 gives us a side length of 9. Then from there to there, we're doing times 3. So 5 times 3 for a side length of 15. And then times 3 again for a side length of 21. Pretty short lesson, guys, but that's all there is to it, okay? Either identifying scale factor or identifying the new side lengths. And this concludes your lesson over dilations and scale factor.